Hello everyone. Today we're going to have the discrete random variable examples. Example. Verify that the following functions are probability mass functions and determine the requested probabilities. For x is equal to -2, -1, 0, 1, and 2, the corresponding f of x's are 0.2, 0.4, 0.1, and 0.2 and 0.1. We will be solving for the probabilities of x less than 2, less than or equal to 2, x greater than -2, x is in between -1 and +1 inclusive, probability of x less than or equal to -1, and probability of x is equal to 2. We will also be solving for the cumulative distribution function and its associated probabilities using cumulative distribution function, and we're going to also solve for the mean and the variance. Okay, so to solve this problem, uh, we first encode the probability mass function as -2, -1, 0, 1, and 2 with their corresponding f of x's, or the probability mass functions, to be equal to 0.2, 0.4, 0.1, 0.2, and 0.1. The conditions are all the probabilities must be positive, and for the total, if you're going to add this, it should be equal to 1. So indeed, we have verified that this is a valid probability mass function. For letter A, we are asked to solve for the probability of x is less than or equal to 2. So what we're going to do is to solve for the probability of x less than or equal to 2. So the values included here would be what? So for less than or equal to 2, so that would include all of these values except 2. So less than or equal to 2 is the sample space. So all of the values are included. So that would be the probability for the sample space. And we know that the probability for the sample space is equal to 1. So this is equal to 1. So let's mark it red. Letter B. For letter B, we are looking for the probability that x is greater than -2. So what are those values greater than -2? So this is the same as, so everything except -2 is greater than -2. So this is 1 minus f of -2. So the values included here are 0.4, 0.1, 0.1, 0.1, or this is 1 minus 0.2. So that would be 1 minus 0.2. So that is equal to 0.8. How about letter C? For letter C, we're looking for the probability that that the random variable x contains values in between -1 and +1 inclusive. So what are those values that includes -1 to 1 inclusive? So that would be f of -1, f of 0, and f of 1. So that would be equal to -1, that is 0.4, plus 0.1 plus 0.2. So the answer is 0.7. So 0.4 plus 0.1 is 0.5 plus 0.2 is 0.7. Letter D. For letter D, we're looking for the probability that the random variable x takes values less than or equal to -1 or x is equal to 2. So this includes -2, -1. So that would be f of -1 plus less than or equal to -1. So that includes -2, -1. What else? So less than or equal to -1 would be -2 and -1 and f of 2. So plus f of 2. So that would be equal to f of -2 is 0.2, f of -1 is 0.4, while f of 2 is 0.1. So that would be 0.7. Now, let's have the cumulative distribution function. So for capital F of x, so that would be equal to f of x is equal to, so that would be a cumulative distribution function. It should always start with 0, and then we're going to add the probabilities until we reach 1. So it would be 0, 0 plus 0.2. Next would be 0.2 plus 0.4, correct. And then 0.6 plus 0.1 plus equal to 0.7 plus 0.2. And then finally 0.9 plus 0.1. And then for their limits, we have x is less than -2, and then -2 less than or equal to x less than -1. So this, we start with -2, and then we have -2 to x to -1, and then this is from -1 to 0. Next would be from 0 to 1. So 0 is not negative. And then from 1 to 2. And finally, we have x is greater than or equal to +2. So this is our cumulative distribution function. So that. We have a follow-up question for that. We are going to apply probabilities. So for letter A, we're looking for the probability that x is less than or equal to 1.25. So this is equal to f of 1.25. What is 1.25? Where does it fall? One 1.25 is here. So 1.25 is 0.9. So less than or equal to 1.25 are all values except 2, so that would also be equal to 1 minus 0.1. Correct. How about B? B is less than or equal to 2.2. So we're looking for the probability that x is less than or equal to 2.2. So this is equal to f of 2.2. What is f of 2.2? So I think it's the sample space. Less than or equal to 2.2. So everything is 1. So f of 2.2 is falling on greater than or equal to 1. So that is, it would be falling here. So it would be 1. Letter C. For letter C, we're looking for the probability that x falls in between -1.1 to x2 less than or equal to 1. So this is f of 1 minus f of -1.1. What is f of 1? So what is f of 1? F of 1 is, when x is 1, it is 0.9. So that would be 0.9 minus f of -1.1. -1.1 is here. So that would be 0.2. So the probability that we're looking for is 0.7. And then for letter D, the probability that x is greater than 0. So greater than 0 is the complement of less than or equal to 0. So that is equal to 1 minus f of 0. So f of 0 is 0.7. So 1 minus 0.7. So that's 0.3. Let's verify. Greater than 0. So greater than 0 is 1 and 2. So that is 0.2 plus 0.1, which is 0.3. So that's correct. Now, let's have mean and variance. So for mean is equal to the expected value of x. So it is equal to the expected value of x. So the expected value of x, so it is equal to mu. So this is equal to x times this is also equal to the summation of x f of x. So what we're going to do is to multiply all x's by f of x. So x times f of x. So we multiply x times f of x. So we do that for all values of x's and f of x's, and then we take the sum. So adding this up, so we can have the mean to be equal to negative 0.4. For the variance is designated by v of x. So this is equal to, our symbol for variance is sigma squared. So the variance is equal to the summation of x minus mu squared f of x. So x minus mu squared f of x. So that would be equal to this is equal to, so to continue, that would be x. So we look for x. So that would be x minus, so minus negative, so plus 0.4 squared times the probability. So we do that for all the terms, and then we take the sum. So we add this. So this is x minus mu squared times f of x. So the variance is 1.64. Another formula is the expected value of x squared minus mean squared. So what we do is to get x squared times f of x. So we square x and then multiply it by f of x. So we do that for the entire table. You check, negative 1 squared is positive 1 times 0.4, 0 squared times 0.1, 1 squared times 0.2. So I think this is correct. So we add that. So that would be equal to 1.8 minus negative 0.4 squared. And then we evaluate that. What's the value of 1.8 squared? 1.8 minus 0.4 squared. So let's check. 1.8 minus 0.4 squared. So it's the same. It's both 1.64. So this is the mean and the variance. If you want, you can take the square root of that to get the standard deviation. You may pause to copy. Another problem. Let us consider the probability mass function given by 8 over 7 times 1 over 2 x for x is equal to 1, 2, and 3. Obtain the following probabilities. The probability of x less than or equal to 1, the probability of x greater than 1, the probability that x is between 2 and 6 exclusive, and the probability of x less than or equal to 1 or x is greater than 1. Determine also the cumulative distribution function for the random variable in the said example and determine the following probabilities. The probability of x less than 2, the probability of x less than or equal to 3, the probability of x greater than 2, and the probability that x is greater than 1 but less than or equal to 2. Determine also the mean and variance of that random variable. So to solve this problem, we're going to use MATLAB. Though you can still solve this problem using the manual computation in Microsoft Excel, but I'm just going to show you how this problem can be solved using MATLAB. I think you have your license here and you can work on this from your previous math subjects. So first, we define a symbolic variable. So we can define x, the random variable x, and then the probability mass function f of x. That. So we know that the function f of x is equal to 8 over 7 times 1 over 2, so 1/2 raised to x, raised to capital X for the random variable x. So 8 over 7 times 1/2 raised to x. I would not be echoing it on screen, so that would be the result. Now if we want to check pre-TF, so f of x is equal to 8 over 7 times 1/2 raised to x. Now we know that x can take value, so I would be using lowercase x. So x takes the values 1, 2, and 3. Such that if we're going to substitute x to f of x, so we can have the probability mass function PMF in the tabular form. So we have x is equal to 1, 2, 3. So we can have the PMF to be equal to substituting f with x. So we have 4 over 7, 2 over 7, and 1 over 7. If we're going to add this, 4 over 7 plus 2 over 7 plus 1 over 7, it would be 7 over 7. So we satisfied condition 2. And if we're going to plot this, so using a bar chart, the bar chart for PMF would be like this. So observe that all the values are greater than 0. So this is greater than 0. So this is the 0 level. So everything is greater than 0. So we know that all the probabilities are positive. So we have the tabulated form, the PMF, and the formula form f of x. So for letter A, so let's have a comment solving probabilities. So for the first one, letter A, we want to get the probability of x less than or equal to 1. So to solve for the probability of x less than or equal to 1, so that would be, we are going to take x less than or equal to 1. What are the values of the PMF? What are the values of PMF with x less than or equal to 1? So we choose from the probability mass function the values of for which the values of x has the values less than or equal to 1. But I think it is only 1 that is less than or equal to 1, so the probability should be 4 over 7. So A is indeed 4 over 7. For letter B, we're looking for the probability that x is greater than 1. So we're looking for the probability that x is greater than 1. So we have solved this already. This time x is greater than 1. So the condition is x greater than 1. So we can first check the values of x greater than 1. What are those values greater than 1? So that would be the second and the third. So that would be 2 and 3. So what we're now going to do is to solve for letter B, which is the PMF with x greater than 1. What we are going to do is to get the sum of all of these probabilities. So the sum of PMF, we take the sum of all the probabilities with x greater than 1. So 2 and 3 are greater than 1, so it should be 2 over 7 plus 1 over 7, so that would be 3 over 7. Next, for letter C, the probability that 2 is less than x and less than 6. So for the values of x between 2 and 6, I think it is only 3. So if we want to check that x is greater x is greater than 2 and at the same time x is less than 6, so it would be the last one. So when x is equal to 3, so 3 is greater than 2 but less than 6. So to get the probability, So to get the probability, so C is the sum of all the probabilities such that x is greater than 2 and at the same time x is less than 6. So it would be 1 over 7. Now for letter D, we want to get the probability of x less than or equal to 1 or x is greater than 1. I think this is the sample space because if you're going to check, less than or equal to 1 is 1 and greater than 1 is 2 and 3. So this is supposed to be the sample space. So, but we can check that. So we check for x less than or equal to 1 or is this operator. That is below the backspace. So x is less than or equal to 1 or x is greater than 1. So all elements satisfies the condition. So for letter D, we get the sum of the probability mass function such that x is less than or equal to 1 or x is greater than 1. So it would be 1. Now determine the cumulative distribution function. So let's have f. So what is f? It is a table that contains the total probabilities or the cumulative probabilities. So f of 1, we start with 0. We have our f for which the first one would be the first probability, so that is f of 1. So we substitute, can we do that? No. So f of 1 is when we substitute f is equal to 1. And then f of 2 is equal to f of 1 plus we substitute x is equal to 2 from f. And then for f of 3, so that would be f of 2 plus we substitute f is equal to 3. So this is the cumulative distribution function. We start with 0 and then 4 over 7 plus 2 over 7, 6 over 7 plus 1 over 7. So that is 1. Now, this is the cumulative distribution function. So, what is the probability of x less than 2? So, we can now write f of x. So, f of x is equal to 0 when x is less than 1. It would be 4 over 7 when x is greater than or equal to 1 but less than 2. It would be 6 over 7 when x is greater than or equal to 2 but less than 3. And it is 1 when x is greater than or equal to 3. So, for some of the probabilities using cumulative distribution. So for the first one, we are looking for letter A, the probability of x less than 2. So this is just f of 2. But since we're looking for value less than 2, so it would be f of 1. So for letter A, we have f of 1. That is the value, that is the boundary less than 2. So f of 1. For letter B, x less than, for letter B, we're looking for the probability of x less than or equal to 3. Less than or equal to 3, so we use 3. So this is f of 3. By the way, less than or equal to 3 is all of these values, less than or equal to 3. So f of 3. So just to check, so for letter B, we want f of 3. So this should be 1. Next, greater than 2. So for the probability of x greater than 2, so that would be greater than. So that is the complement, 1 minus the probability of x less than or equal to 2. So that would be 1 minus f of 2. So 1 minus f of 2. So letter C is 1 minus f of 2. 1 over 7. So greater than 2 is the last one. So that is 1 over 7. For letter D, we have the probability that it is greater than 1 but less than or equal to 2. So that would be f of 2. 2 is included, so f of 2. Greater than 1. The value that is greater than 1 is so minus, we can have f of, let's have greater than 1, so we can have f of 1. So greater than or equal to 1 is okay. So this would be D is equal to f of 2 minus f of greater than or equal to 1. So f of 1 is this one. So f of 2, when we say greater than 2, less than or equal to 2 but greater than 1, it is only 2. So this is f of 2 minus f of 1. So f of 1, so that is 2 over 7. So from our probabilities, 2 over 7 yung second one. Now, let's have now the mean and the variance. So mean is mu equal to the expected value of x, which is the sum of x times f of x. So to compute for the mean, what we are going to do is to take the sum of the products of x and f of x. What are the x's? So we have x dot asterisk to PMF of x. So if we're going to multiply x to its corresponding PMF of x, we will be having, if we're going to multiply x to its corresponding probability mass function, we're going to have the mean. So before we do that, let's first recall what is x and what is PMF. So what we're going to do is to get the mean, which is equal to the sum of all x's times the PMF. So it would be 1 times 4 over 7, 4 over 7, plus 2 times 2 over 7, so again 4 over 7, plus 3 times 1 over 7, so 3 over 7. So 4 over 7 plus 4 over 7 is 8 over 7 plus 3 over 7 is 11 over 7. So that is the mean. While for the variance, variance is equal to the sum of x minus 11 over 7 squared and then times the PMF. The dot asterisk here refers to the element-wise multiplication. So we multiply 1 by 4 over 7, 2 times 2 over 7, and 3 times 1 over 7. So just to check or just to show you that it is really x dot asterisk PMF. So this is what we have been solving: 4 over 7, 4 over 7, and 3 over 7. So if we want to do that for variances, so we can do this. We subtract x minus the mean squared times the PMF. Oh, sorry. So this should be element-wise raising to power 2. So that would be that raise. And then to solve for the variance, that would be the sum of x minus 11 over 7 squared dot asterisk PMF. Sorry again. This should be that raised to 2. So the variance is 26 over 49. These are the references used to make this video.